We have some questions here. So load, inspect, and clean. Load the IDS from the user URL below using pandas, and add proper column headers. So we're gonna import pandas, and we're gonna save this URL in a string. We need some names as columns since this dataset does not come with a header. So the IDS dataset has these 5 columns. So sepal length, sepal width, petal length, petal width, and finally the name of the flower. So once we have that, we can read the data frame with the URL, and the names would be false. So yeah. The second part is check D types. I'm gonna print and see what data types are these. So 4 floating data columns and 1 of the object data types. Check for nulls. So we would say that print df is null, and then we're gonna sum so that it gives the summation of the rows that has null values in it. We do not have any null values in any columns. Strip any trailing white space from the name column. So df name will be df name str dot strip. So print the value counts of name. So lastly we have to do this df name, okay, value counts. All right. So yeah. Feature statistics, par class. Using group by compute the mean and the standard deviation of all 4 numeric features for each species, then identify which feature has the highest coefficient of variation globally across the whole dataset. First, we're going to use group by syntax to handle this part. So group by should be used to compute the mean and standard deviation of all 4 numeric features. So skip skip B. We would be doing stats equals df group by. We group by the name, and then we would pass in the list over here. So false minus 1, that should do. And we're going to do this aggregated value. We're going to group by the label name and then show for each of label names the aggregated mean and standard deviation of those 4 columns. So that will be mean and that will be standard deviation. And over here, this should be a list like this. Then we're going to print it in stats. So yeah. The second part is identify which feature has the highest coefficient of variation, STD divided by mean, globally across the whole dataset. So we're going to go and add those numeric columns. You have those columns already in the calls. Okay. This cov would be numeric dot STD divided by numeric dot mean. After that, we have this highest co feature. Cov.idx max. So petal width has the highest covariance feature. Encode labels in split. Using sklearn, encode the name column to integer labels with label encoder. So we have this label encoder from sklearn.preprocessing import label encoder, and we create a label encoder variable, and then we have this label column which would be df fit transform df name, and we're gonna see that this label would be some numeric value, a 0, 1, and 2. They corresponds to the 3 names. Now the second part says split the ratio into train test with age window ratio and random state 42, and we're going to do that now. Okay. Now our training dataset is actually false except the last 2 columns now, and I would just do a verification. So this I guess like columns does not have a label column over there, so the x value would remain the same, so false minus 1, and y would be df label, and we have to use these values and over here as well. So these x and y are this, and x train, x test, y train, and y test should now use from sklearn.model selection import train test split, and x train, x test, y train, y test equals train test split x, y. Test size should be 20% and random state would be 42. And we need to stratify the y labels so that they're evenly distributed with model balanced labels. Over here, we would say that we can print the pd dot series and do this y train and then value counts and do this normalize equals true, and we're gonna see that all this model has equal proportion of counts. And for the test dataset, we're gonna do that once again. So pd dot series y test dot value counts normalize true. Yeah. Apply standard scalar to xtrain and xtest. So from sklearn pre-processing import standard scalar, and over here we're gonna see that we need a scalar variable which is this, and we are gonna do fit transform on xtrain, and we're only gonna transform xtest. So x underscore train is for scaled, so scalar dot fit transform x train, and x test as equals scalar dot just transform on x test. So ideally, after doing the scaling operation, the mean of the train dataset's value should be around 0 and the standard deviation should be around 1. So we are going to confirm this. So we would say print train mean should be around 0. So that will be done by np.round, right? Xtrain s dot mean s.mean. So we're rounding this to 4 decimal digits because if we just output the raw value of this mean, they show a number in the engineer format with a very small number with a very negative exponent. So if that is very close to 0, and that's why we're rounding it to 4 digits so that we directly see 0. And print train std, it should be around 1. All right. And np.round x train s dot std, and then okay, where's the round function? All right. So here we're gonna see the mean. Okay, I think there should be 4 columns. I'm seeing just 1, and I need to add axis variable over here, axis 0 and axis 0, so that it shows the row wise values. And now I'm seeing these 4 values for 4 numeric columns. All of them has been scaled so that the mean is around 0 and the variance is standard deviation is around 1. So convert to PyTorch tensors. So convert xtrain, xtest, ytrain, and ytest into PyTorch tensors with correct dtypes. Features should be float 32, labels low. Now let's do this. Over here, import torch, and we're gonna do this x underscore train. That would be torch.tensor, and we would pass the scaled dataset xtrain s, and dtype should be torch.float 32, and x t equals torch.tensor x test s, and dtype equals torch.float 32, and y train equals torch.tensor, and y underscore train comma dtype torch.long. So y test equals torch.tensor y underscore test, dtype is torch.long. Okay, so the second part over here is wrap train data in a tensor dataset and a data loader with let's say 16 and shuffle through. So we need to import from torch in utils data. So import from torch utils.data, import tensor dataset and data loader. Now train ts equals tensor dataset and x underscore train, y underscore train, and train data loader equals data loader. That will be taking this train dataset with batch size equals 16 and shuffle equals true. Alright, we're going to print out the number of batches per epoch. So batches per epoch is what? That will be len train underscore dl, so f string over here. Alright, there should be a okay, let me just syntax error. and X batch and Y batch should prepare the next batch. So we're iterating through train here, and we're gonna print xb dot shape and yb dot shape. So